and welcome to Epiphytic Cacti. Today I want to take a look at morphological variation within a given species, and we're going to use Hadiora salicornioides for this specifically. The reason why is because I've collected so many of them over the years, we have a lot of samples to look at. And before we get into that, I want to read an excerpt from Nadia Koratkova's dissertation that was published in 2011 by Bonn University. The name of it was Phylogeny and Evolution of the Epiphytic Rhipsalidae Cactaceae. In Chapter 3, Section 3.4.2.2, there's a little section about Hadiora, specifically from what they found when they were doing the phylogenetic study. It says that our data reveal Hadiora as polyphyletic. And what polyphyletic means is a group of organisms derived from more than one common evolutionary ancestor or ancestral group, and therefore not suitable for placing in the same taxon. And what it's saying is that at the time of this study, when there were more species that were classified under Hadiora, they found those species to be polyphyletic, and so they have since been moved out. It goes on to say the generic name should only be applied to subgenus Hadiora, which includes taxa with cylindrical stems, a terate pericarpal, and small yellow, orange, or magenta flowers. The corresponding clade of Hadiora salicornioides, the type species Hadiora cylindrica and Hadiora herminiae, is highly supported, and the morphologically different magenta flowered Hadiora herminiae is resolved as sister to the other two species. Hadiora cylindrica falls into a clade of Hadiora salicornioides specimens. The main characteristics of Hadiora cylindrica are cylindrical stem segments, a fully expanded perianth, and deep red fruits, while Hadiora salicornioides has bottle-shaped stem segments, flowers which do not open widely, and white fruits. Our data indicates that Hadiora cylindrica might either not be a good species, but a form or variety of Hadiora salicornioides. So today, when you look at the taxonomy of salicornioides and cylindrica, you find that they are actually grouped together under the same species, salicornioides, and one is form salicornioides and the other one is form cylindrica. And this is the explanation for why that was done. But it goes on to say, but it is also possible that what is known as Hadiora salicornioides is more than one species. This is even likely because very distinct races and ecotypes exist in the wild. Some Hadiora salicornioides forms have been described as separate taxa, but the species limits are hard to define because of integrating characters and further differences possibly attributable to cultivated plants. So the additional species names are currently treated as synonyms. It's worth saying that in this particular study, only one clone of Hadiora salicornioides form cylindrica was sampled, and 3 clones of Hadiora salicornioides form salicornioides were sampled. So within the population of the 4 plants that were sampled, there wasn't enough diversity to warrant any kind of distinction in subspecies or species status. Let's take a look at the variability within the clones that I've managed to collect just out in cultivation. This is a very classic form cylindrica. You can see that the branch segments make perfect cylinders. There's not a lot of tapering at the base. There's not a lot of tapering at the tip. It does have an overall kind of bushy habit. You can see that the new branch segments form from the old branch segments, the very tips, and they tend to form in groups of 1, 2, or 3. And so it just continues to sort of multiply out like that, again, creating this rather bushy habit. I will say that I have seen clones out there in cultivation that have a more upright appearance. As a matter of fact, a very famous one would have been Hadiora bambusoides, which has been reduced under Hadiora salicornioides form cylindrica. However, there is some confusion within bambusoides, and the one that I am specifically talking about would have had an upright habit with very smooth cylindrical stem segments. The name was derived because the overall growth habit resembled that of bamboo shoots. Here is a look at a more common looking Hadiora salicornioides form salicornioides. And you can see that indeed the branch segments form these perfect ideal little bottle shapes. The plant is very pendant, and as it ages, the older branch segments get very thick and very woody. This particular plant is extremely pendant and was right out of the gate. It is a little bit strange in that the phylloclades, they are sort of twisted, curved, and contorted, maybe a little bit monstrous looking. You can see here in comparison to a very classic looking Hadiora salicornioides form, salicornioides to the right, and this kind of contorted one on the left. On the right, again, we have just a very classic one. You can see this also has these kind of ideal bottle shapes. The growth habit can initially be more upright, and then as it creates more and more phylloclades, it just gets heavier and heavier and eventually ends up being pendant. But I do want to point out, and it's kind of a curiosity, that it does initially have that upright growth. This plant in the back here is really interesting because it is another plant that would have carried the name Hadiora bambusoides. And that is, again, there are some oddity there about how a couple of different kind of plants ended up having that name applied to them. And the general trait that they all shared was that they had a very upright growth habit, and they maintained that upright growth habit. Now, this one does not have super slim, perfectly cylindrical branches that look like bamboo shoots. Indeed, they are actually kind of rough and seem somewhere in between the perfect cylindrical shape of form cylindrica and the kind of tapered shape of form salicornioides. But the plant maintains an upright growth habit no matter how tall it gets. So this plant can grow several meters tall. It is really just an absolutely wild, crazy thing to see Hadiora salicornioides grow this way. But like as we just saw in the previous plant, that one, it could potentially have upright growth, but eventually just got so heavy that it would hang down. So it's not so bizarre that we might have one that can grow purely upright. Let's say that you have Hadiora salicornioides growing in a nice, shady forest. It's growing epiphytically, it's growing in the crook of a tree. A bird comes along, eats the fruit, flies a distance away, and goes to the bathroom on a rocky cliff face with full sun exposure. The seeds germinate, and the ones that are genetically more capable of surviving in that area are going to survive. That's called natural selection. But you're also going to have this thing called phenotypic plasticity at play for a little while, which is them altering their appearance based on environmental stimuli. So suddenly they're in a much higher light area. And so a couple of things are going to happen. Like they're probably ones that are capable of producing more betulins, probably the ones that are going to survive better, probably going to have more of a reddish flush to them. The plant's probably going to grow more short, squat, upright, probably will produce more bristles. Like a whole lot of things can change just based off of that one thing, sun exposure alone. But if you take those initial early plants and you take cuttings of them or you take seeds from them and you relocate them back to where they originally came from, they will alter their appearance back to look like the original plant. That is a temporary change, and that's what phenotypic plasticity is. However, the plants that are growing now lithophytically on this rock face in full sun, over time, it's going to continue to reproduce there. And because of that natural selection, it will genetically continue to change to a point that those changes now become stable. And if you take the plant and you were to take cuttings or seeds and you were to relocate them back to where the original epiphytic plant was growing, they will no longer have the ability to change their appearance back to the original plant. At this stage, they have not genetically changed enough to be classified as different subspecies or different species. They're still the same species. They've now just altered their appearance from each other to such a degree that they look different. And that is the idea of clonal variation, how we can get the same species, multiple plants in cultivation that can look drastically different. What's interesting is in the example that I used of an epiphytic cacti growing epiphytically versus growing lithophytically, the lithophytic plants have a strong tendency to grow considerably more upright. So is it possible that we just ended up with these upright Hadiora salicornuates specimen because they were growing lithophytically and collected, and they now are genetically stable enough that they maintain that appearance? Totally possible. It's not uncommon for quite a few of the epiphytic cacti species that we talk about to be found growing both lithophytically and epiphytically. Here's one of my favorite examples of this is Rhipsalis aurea from this field guide, where the right one is growing lithophytically and the left one is growing epiphytically, and you can see the extreme difference in their appearance. Now, if these plants didn't have flowers and you found them in cultivation, you would not believe that they were the same species. And that is kind of a weird thing with collectors, that there's kind of a struggle there, because a lot of times we're looking at our plants and we're like, oh, these don't really look the same. But that may just be clonal variation, just like this. The extreme woes of epiphytic cacti identification. Here we have another really interesting appearance change. This is something that all epiphytic cacti are capable of producing. And the reason why they're all capable of producing this kind of growth, this juvenile growth, is because they do it when they're seedlings. So in a very young sort of seedling stage, they all tend to have kind of unusual, different, bristly looking growth that is really, really different looking from their adult stage. Now, some plants maintain variations of like bristly growth into their adult stage, and that's not necessarily considered juvenile growth. In cases like with this Hadiora salicornuates form cylindrica here, a piece of a branch broke off and the piece of the branch was small enough, i.e. it didn't have enough mature growth on it, that the new growth reverted back into kind of a seedling stage. And that will eventually grow out and go away, and it will maintain more of the adult growth appearance. It's also evident that this particular Hadiora salicornuates form cylindrica has much shorter stem segments than the more mature adult ones that I have. And that, again, is just because it's a young plant. That can be another extremely tricksy, bizarre thing with epiphytic cacti. Here is another example of one that's producing an abundant amount of juvenile growth. And this is from some small phylloclades that fell off of the upright plant that's in the background. And you can see, because these were like singular phylloclades, it was just a grouping of very small sections of phylloclades. Because they were in such a young stage, the plant now has just a ton of this bushy, bristly, short juvenile growth. And you can see in some places it's finally starting to come out and get enough maturity on it to produce more of an adult type growth. But when you take cuttings that are large enough that they have enough mature growth on them, the plants don't always do that, or don't do it to that degree. Here's an example of a section of that same plant in the background that was started, but it was a much larger, much more mature section of the plant. And you can see that it does not contain that ridiculous abundance of juvenile growth. And just for good measure, here on the large plant that was in the background, you can see a couple of phylloclades having fallen off and landed in the substrate. And because they were such small sections, they obviously have a large amount of that juvenile growth. Again, there has to be some benefit to the plant of producing that kind of growth. And you can see that it is very apparent when the plant does not have enough overall energy to produce like real mature growth. Here we can look at a couple of different epiphytic cacti that are in a different genus. So here we have some Schlumbergera, and you can see this seedling, you can see its young growth has all those bristles on it, and they don't have the same appearance as that kind of truncata-ish looking clade that it eventually produces as it gets enough energy to produce that kind of growth. Here is another little Schlumbergera, and you can see the exact same kind of thing. It's got a wildly different kind of growth appearance in a juvenile state than it does in an adult state. And every once in a while, you may see something strange happen, like when the plant is under stress or whatever, start to revert back and produce juvenile growth in an attempt to reproduce itself. It's really kind of wild. I see that a lot with Disocactus hybrids. Speaking of, these are Disocactus hybrid seedlings, and you can see once again this bristly juvenile growth, and then eventually it will start to turn into more of an adult stage growth as it gets enough maturity on it. But sometimes if you were to take too small of a section of this adult growth and you were to try to start it, what will end up happening is it will revert back into that juvenile growth stage for a short period of time. That is really just to point out that sometimes things can be a little bit complicated, especially when you buy young epiphytic cacti, that they may really alter their appearance over time. Let's take a look at more clonal variation in Hadiora salicornioides. So this particular plant was found in cultivation. I believe that it originated, as far back as I could find anyways, from I think Rainbow Gardens. This one came with the clone ID of new ISI 9510. Not to be confused with ISI 9510 because that is a different clone, bizarrely enough. This one produces flowers that are really interesting. They have a pinkish kind of rim to the petals. You can also see that for the time being, this plant is growing a little bit more upright, although it does also appear to be a little bit more bushed out. You can see that it has phylloclades on it that both carry kind of more of the shape of Hadiora salicornioides form cylindrica, and also has kind of the club-shaped phylloclades that are more narrow at the base, so more like form salicornioides. And that actually is one of the things that makes determining identification on these a little bit difficult. But I do believe that I have seen the fruit on this plant, and the fruit was in fact white. So I think this plant would have to be classified as form salicornioides at this point, just based off of the current taxonomic definitions that we're given. FYI, if you see ladybugs running around all over the plants, perfectly normal. I release them as predatory insects through my collection at the beginning of winter because they eat mealybugs. So just kind of preemptive when they very first come in. So that's what that particular clone looks like. Now, if we take a look at ISI 9510, which again is a different clone, this one has more yellow flowers that they kind of have like little reddish tips on it. And this is not a mature specimen, and actually half of it is dead. So you can see this one looks kind of similar. It's got those same kind of like, some of them are club shaped. They're a little bit rougher looking. They're not so smooth. And that's kind of what that one looks like. But you can see some of the variation that we're already seeing here from clone to clone. Now, here's another one, and this one you can see is kind of carrying a similar appearance, but this one is actually Bambusoides, or one that carried the name of Bambusoides historically, this particular clone. So this is probably exactly the same as the clone that I had in the background that eventually grows very tall and upright like that. Here's another one. This one is AH650. And so the AH here stands for the botanist Andreas Hofacker. And so you can see how this one has very, very, very prominent little bottle-shaped phylloclades. And you can see how they're elongated, and the base of them is extremely, extremely long at this point. The clades do look a little bit, I guess, kind of knobbly and gnarly, but you can see that this plant carries a different appearance than any of the other salicornioides that we have previously looked at. So this one is AH565, And I am immediately going to point out that half of this plant is not alive, but I'm also going to say that this plant seems to be very capable of producing betylins. You can see by the reddish coloring on some of the phylloclades, whereas some of the other ones that we previously looked at, not so much. You can see how the phylloclades are very long and slender. The bottle shape is there, but it is less prominent, and again, very clearly has a different appearance than any of the other ones that we have looked at so far. Here we have another one that appears to have more of an upright appearance. I do not know how to say whatever that clone name is. Gotten again? I don't know. But again, it has these very kind of gnarly, knobbly looking clades. It has not so much of a bottle shape on this one. Again, some of these are somewhere right in between the two different forms where it's kind of head scratching a little bit, because they don't quite seem to totally fit in one or the other, so we have to use those other characteristics. But again, a little bit of a different appearance. Kind of looks like some of the other ones, but kind of not. Clonal variation. This one is AH687, and you can see again we have some that are very, very tapered. They're very narrow. They're very, very elongated, and it also looks like to some degree this one would be able to produce some betylins and flush the branches red. Again, different from any of the other clones that we've already looked at. That is really what clonal variation is. Now, is it possible that if all of these different clones were sampled in a molecular phylogenetic study, that we would find that there are indeed either more forms, or that there are more subspecies, or that there are distinct species? That is possible. It's also possible that it really is just clonal variation. But I also feel like there are some really interesting lessons to be learned here, just about how much variability could possibly be in the same species in your collection. Obviously, quite a bit. But I also think that it's something that we can learn from in terms of what would happen when a botanist maybe describes a plant out in the wild. So we have those botanical descriptions, the botanical sketches. And I think it's just really important to know that a lot of times when they were doing that, they were looking at one small population of these specimens, or even just a singular specimen, because sometimes they weren't even found in the wild. Sometimes there was a specimen that was found in cultivation and then described. So we may not know the full gamut of the appearance of that particular species, other than the very specific population or specimen that was described. There's also something really cool to learn about phenotypic plasticity here. On many occasions, I have received plants from varying different collections or even different countries, and over a course of just a few months in my collection have drastically altered their appearance just because of the environmental change. I've seen phylloclades on Ripsalis go from being flat to all wavy on the edges. Like, what? Right? I mean, totally different. I've seen the phylloclade shapes completely and totally alter in shape from when I initially had it to just a few months later, just because of the environmental changes. And so sometimes you may want to give the plant a little bit of time, because one that I've had that I know has been extremely tricksy has been like Ripsalis gobeliana. I have received that plant with like a certain kind of clade shape, and it looked like it was different and it seemed like it was different, but then a few months later, it just looks like every other Ripsalis gobeliana in my collection. So sometimes things are just a little bit wonky like that. And that a lot of times is what botanists talk about when it comes to epiphytic cacti classification. Why and how it can be so horribly hard to classify and even to identify them. Anyway, I hope that you've enjoyed taking a look at just clonal variation with me. Thank you for watching, and as always, happy cacti growing.